I started with like, there's a problem that is like running. Is that you have a heads up. Let's let somebody start a little earlier. Okay. Yes?
I was just going to say it helps me to remember for the slope to just say rise over run.
Yep.
Like that's how when we're in algebra, it was always how much you're going up and how much you're going this way.
Yep.
It has nothing to do with like the coordinates.
Right. The coordinate is a format. Okay? Coordinates is a format of how you represent the dots on here. All these dots are coordinates. They have infinite number of dots. Okay? That's the format. The A has to do with the relationship between the rise and the run. Right? Or I just call it like, you know, how much is changing, you know, so kind of whatever words you want to use. Doesn't matter. Okay. It's actually really cool. If you understand it, it's not that hard. But if you don't understand it, you're always trying to figure out which number go where, and how do I know which number should I plot. But once you know it, every problem is the same. Every problem is the same. If you can pull it into this way, you could literally draw it without having to put a table. Because the long way of doing this is to do this. Okay? Y. And then it's equals to, what is it? What is our say? 1/4 x minus 1? Oh no, the other way around. Yeah, it's correct. So when I say, when I say x, this is y. If you want to do the long way, I'm going to start with 0. 1, 2, 3, 4, 5, 6. Alright? I might have to even do a -1. That means I have to take every one of this, make the point, and then pi. That's a long process. That's a very long process. So sometimes math is a language, which means you're trying to be efficient. You don't want to say, oh my God, I'm going to have to plot this every time you give me an equation to draw the line. It will take me forever. Okay? But if you understand the relationship, I don't need to do this table. I know exactly what the line would look like by the virtue of this. So would somebody want to try drawing that line for me? So now that we figure out that y equals to 1/4 x minus 1, and we say that the slope is 1/4 and the intercept is -1. So how would you draw that? Anybody want to give me the shot? So I'm going to set it up for you. We'll just do a graph. And this is x, and this is y. So anybody, and we can maybe put a dot here in the middle. Is the invisible one? That's the middle. That's the one.
So how does that relate to 45 degrees and 90 degrees? And then does this all?
Yep, this is a 45 degrees because it's x equals to 1 and y equals to 1.
So if you're calling kind of 45 degrees, you're 1.
Yes.
Okay.
Yep. So if your slope is bigger than 1, your angle here will be bigger, right? But usually we don't talk about it in angles, but we just talk about it in the fact that there is a line right in the middle. That is the y equals to x. So would somebody try to plot this? Y equals to 1/4 x minus 1. Anybody want to try? Anybody want to try? You want to try it on your own first? You want to try it on your own? Like how would you draw this? Like what does the line look like on there?
You begin with -1. It's y.
Okay, you begin. You want to come and do it? Or you want to tell me how to do it? There you go. Tell me what to do.
Begin from -1.
And why do I do that?
Because there's a y intercept.
Does everybody hear what she just said? Right? If it was a 0, we would start with 0. So I know my line is going to cross -1. That's what the intercept means. Okay, you're intercepting y. All right. So I'm going to start here, and then what?
And then that one is really confusing. I cannot remember really well. Is it going up first or going to that way first? But you go one off or south?
Well,
I just cannot remember.
so think about what we just said. Is a quarter steeper or less steep than 1? Less steep. So let's say that if it was 1, how would the line look like? It will be like right in the middle.
Okay.
Right? So you always have this imaginary line with you, okay? When you don't remember, always draw the one that is exactly like 45 degrees here, because it's exactly 1 to 1, right? So if I draw that, now I know if it is a quarter, it's going to be less steep. So therefore, then my line probably should be somewhere like this, right? Because it's less steep. Again, I don't need to know the exact numbers, but I do know that it's less steep than 1. If it was 1, it would be the dotted line that I wrote, right? This would have been y equals to x minus 1. This is y equals to 1/4 x minus 1. Okay? And if I want the line to be really steep, it could be y equals to 4x minus 1. And do you see why minus 1 stay the same? Because that's the intercept. It's crossing y. And the x equals to y equals to x minus 1 just means that I have an exact same amount. So you're going to be able to visualize the line right in the middle between x and y. You're going to be able to visualize that. Or put a dotted line. So you can visualize it, and then you know that you're going to draw it right lower because it's very, very, very small slope, right? 1/4 is not very steep. Okay?
Are they going to ask us to draw that slope, or are they going to look at a slope and then tell you to draw the equation with the comma?
Yeah, they probably will ask you and say, what equation describes this line the best? Right? So they might give you all 3. Right? They might give you all 3. So not understanding slope will disadvantage you. So understanding slope, you will go, whoa, wait a minute, this is like not very steep. So right away, like they might give you things like y equals to 1/4 plus 1, just to trick you. 1/4.
So you know right away it's not that one because it would have been a +1 in a 6 point.
Exactly. Right? So sometimes you do it by elimination. Right? Don't get all panicked and go, oh my God, I'm going to do a table, it's going to take me a long time to plot. You don't have time to do that. Okay? All you do is say, look at the answers and say, which one I know already that it doesn't work, right? If it was a +1, you know, the test will trick you that way. Because it looks good, because there's a 1 in there, and but there's a -1. So you know that's not right. But that requires that you understand that's the intercept. And then it requires you to understand, is this line going to be cutting right in the middle between x and y, or is it going to be lower or higher, right? Is it less steep or more steep? Knowing that makes all the difference. Then you will choose the right answer, right? Because I have a feeling that they will put like this and this and this, and maybe put a +1, and then put a x +1, right? There are different ways, and the numbers are the same. It's just that they are not matching what the graph says.
Right.
Partly because you have to understand this, right? This is one of the most important things you have to understand. Slope and y-intercept. Okay. So when the problem doesn't look like it, change it. That's the reason we ask you to do a lot of practice in changing, isolating a variable, right? If you practice that a lot, when you look at this problem, you're going to go, I don't know how to plot that. I don't know what that looks like. Isolate y, right? Isolate y into this format. And once you isolate, your line becomes a lot clearer. For how many of you this is helpful? Even if you think that you know how to do it mechanically, even the explanation is hopefully it's helpful, right? Because you have done a lot of this kind of problem before. But how you actually explain it makes a lot of difference because it becomes again a logical way of understanding the pattern between x and y, right? The pattern of how the line looks like because of the relationship between x and y. And always start with y equals to x. If you always forget, start with y equals to x. Y equals to x. So you know that it's steeper or less steep. And then depending on whether the line is going up or going down, right? And then sometimes you have a negative slope. When you have a negative slope, you turn the line the other way. Okay, that's the whole. So if you have a line that is this way, what would that line be? If I have a line this direction, it's going through right in the center. This is y equals to x, what would this be?
1. -1.
But how do you write it? Because there are many dots here, many points. So how do you write the relationship between y and x?
Just pick a point.
Y equals to
Negative 1.
y equals to negative 1.
Negative x. Y equals.
B is 0, right? Because it's going through here, so B is 0. But what is the relationship between x and y? That means if I go here 1, do I go up or go down? I go down 1.
So you get negative 1.
Just 1.
And
What?
then
I know. This is hard. We do this all semester. When I teach algebra, this is also.
This is not going this way, it's
Right.
going this way, so it's gotta be negative.
You know it's negative somewhere.
Right.
Okay? So the slope here is 1, right? Remember the slope here is 1? So when you have the line going the other direction, what is the slope you think? Negative 1. Negative 1. So slope is negative 1. Y is not negative 1. Ah, remember y is changing.
Oh, so okay, it goes through 0, so y equal negative x.
Does everybody agree, disagree? So I'm going to write this down. Y equals to negative x because it goes to 0. The b is 0. And I can think of it as minus 1, right? I can put a minus 1 in front, you with the same answer.
Yeah.
Right? So when you guys say minus 1, I can see that it's a negative. But what you didn't say is that the slope is minus 1, not y is minus 1. The slope is minus 1. Yeah. Yeah, this one?
Yeah, I see when y is equal to 1, the answer became like positive 4 for x. So how x, we have x as 1/4, as a quarter.
So why did it become positive?
Yeah,
It's because when you multiply two negative numbers, it becomes a positive. So when you multiply negative 1/4 times a negative x, it becomes a plus. Okay?
x is equal to after that.
Yep. So that is x 1/4 x because the minus and minus become a plus. So that's just another rule of mathematics. That 1/2 minus 1/2 times say minus 4 is equals to 2. Okay, because the minus and minus become a plus. Okay, minus 2 times minus 3 becomes a 6. Okay, minus and minus give you a, okay, all right. Okay. This is a whole class of algebra. Now you guys are supposed to have taken some algebra in college, isn't it? Long time ago. And some of you might have taken it where you just do a lot of problems, but really not deeply understand the concept. Could be.
I took it last year that was not real.
Not real?
No. It was just Fibonacci numbers and figuring out like,
Math for liberal arts.
that's
Oh.
the not real, that's me.
Oh, so it didn't really help you with some of the fundamentals. This is so
It didn't
fundamental.
address the single fundamental, period.
You know, do you realize that, I'll let you guys know this. One of the reasons that some people would say, why do we want teachers to know this? Okay. Guess what? When you are teaching elementary and you start talking about stuff like, yeah, if you take 3 steps here, somebody's going to take 3 steps in that direction. Or you start looking at patterns, you're not doing algebra with them. Okay? You're just doing like simple things. You're actually doing algebra. When you say stuff like, if I have a missing thing, and I know this is 4 and this is 2 and there's something in the middle that is missing, what is that? You are doing algebra. You just don't call it x and y. You just call it like a little question mark or a little box, right? You know how in elementary you do stuff like this, right? Plus 4 equals 6, right? What is that in there? You are doing algebra because that could be an x, right? So the reason we would like, how many of you are elementary? Yeah. In elementary, sometimes people think that we don't need to know all this math. Absolutely you need to, because you are actually doing algebra from a very young age. Okay, when you start looking for patterns, when you start looking for shapes, it's just that you are doing it in a simplified version. You don't have x and y, intercept and slope, but you have ideas of patterns. You have ideas of when something changes, something else changes. Okay, when I do this, I get this result. When I do this, I get this result. That's algebra. Okay, so don't think that we're gonna just pass this because once I'm done, I don't ever need to use it. But the idea of looking for patterns is so important. So somebody help us look for the pattern so that we came up with this equation. That it works every time. That's the magic of it. It works every time. And so I shouldn't say magic because algebra is not magic, but it feels like magic because it works every time. Because the pattern is exactly the same, right? So you know what this means? When you do some of the algebra problem, if you can put it into this equation, you should be able to draw it. That's the key. That's the practice that you need to have, right? And you have the keys to it. So maybe you can go, wait, how did they get it? Did I put it in the right form? If you don't put it in the right form, you won't be able to draw it. Okay? The slope and intercept. Slope and intercept. Those two things are very important. And remember the word. Intercept means I'm actually cutting through, right? Intercept, I'm intercepting something. I'm cutting through y. Okay. Slope means rise and run, or whatever, how think of walking, right? Think of this drawing, right? Like, oh my God, this is so steep. This is less steep. And this is not in the middle. Okay, 1 to 1. 1 to 1. Yes?
When you say slope, is it always just the rise, or is it both?
Rise over run, right here. The definition is always the relationship. That's why fractions are so important. Okay? By definition, slope is a relationship between the rise and the run. And how do you do that? Put it in a fraction. Okay? Fractions are actually an amazing thing. Okay? It always helps you describe a relationship. The top number to the bottom number. Right? Slope is always, so you could say rise over run. Okay? Rise over run. How much you're going up versus how much you're running towards something. Yeah?
Is it okay if you do one more problem similar to this for those of us who need a little bit more refreshing?
Okay. Now, so how many of you are already working on the geometry one? Or you think, I'm looking at the time, so I know for some of you this might be review, but hopefully maybe you want to do one more?
Yeah.
You want to do one more? As I say, I do this for a whole semester of algebra, so this is kind of like, we're trying to do it in like an hour, so. But to me, kind of helping you understand algebra is different than saying, do this formula, go plug in the x and plug in the y, right? Because then guess what, you panic. Right? All right. Somebody want to pick something? Pick something in the algebra packet. Pick something. May I erase? I wish I have like a board that is so big that I can start from one end to the other. I feel like I'm like starting on this end and then I go back to the other side because I ran out of room. So that's my problem. I take up a lot of room for a little person. I use a lot of room. Okay. Oh sure. Okay. Yeah. Okay. This is the last one. Is that right?
This one right here.
The last one? Is that the last one with the 5,000?
Yes.
Okay. But someone.
Oh, 5,000.
I know. Those big numbers scare us, huh?
You gotta reduce it down. Sounded good.
Sounded good, huh? But remember, whatever you reduce on one side, you reduce on the other side. Right? That's the whole thing about mathematics. Would some of you want to maybe work with each other on that one, just to see whether you can talk through it? Find somebody to talk through it while I erase this. Make sure you understand the problem first.
Is the green part?
I think so. I think so. The green is the answer. They are showing you how to do it, isn't it? So see whether you understand it. I'm going to leave some of the stuff here, just so that because they are applicable for all problems. Okay.
So y is the value of the whole car. And x is the number of years. This is the slope.
What is the problem asking you to do?
Find the y and x intercept.
I know, I'm sorry. No, it's good.
Math speaks.
It wants us to find the y and x
Well,
intercept.
that's my advice to the students too. Well,
I don't know if there's a, I mean,
Maybe it wasn't.
but you know, so what it's saying is that if you look at the example, could somebody read that? It says consider the following example. Could somebody read it?
The value of a new SUV is given by the equation y equals negative 5,000x plus 30,000, where y is the value of the SUV and x is the number of years after purchase. Find both the x-intercept and the y-intercept. Interpret the meaning of each context of this problem.
Ah, okay. Okay, so don't look at the green yet, okay? Because then maybe when you review, you will make more sense, right? So, on the test, you are unlikely to get problems where it is what I call naked problem, where it's going to say y equals to blah blah blah, just solve it. Usually it will be a problem where you have to figure out what is y, what is x, what is the variable, what you're going to try to do. Okay? So for this problem, let's make sure we understand the equation. Is it in the format of y equals to as plus b and some water?
Yeah.
Is it? Okay, where's my water?
Yes, it
Oh,
is.
there you go. Thank you.
Yes, because we could use that and it always works.
So it's negative 5,000.
Yeah, so say y equals, oh, this is the one that didn't work.
Oh, so y equals
So let's write it right underneath, okay? Y
5,000.
equals to, what is it?
negative 5,000 x plus 30,000.
Oh my God, these are big numbers, aren't
Yeah.
they? They are big numbers. So,
SUVs are expensive.
SUVs are expensive, that's right. Yes, in real life, you don't deal with numbers as 1, 2, 3. It's like big numbers, like money, right? 30,000 of a SUV. So what is y again? In your own words, what is y again?
That's
The value of the car.
The value of the SUV. And then what is x?
The year.
The year.
Of years after years.
Okay. Now, isn't that interesting? So logically,
And then the
do you think that the value would go down or go up over the years?
Down.
Go down, right? Go down. So we already know that, okay? Knowing that, guess what? Remember what we talked about? Oh, I just erased that. We talk about this. If this is y equals to x, right? Do you think the problem will be sloping this way or the other way?
The other way.
Right away, because you know your value is actually going lower. Okay? Your value is going lower. Okay, it's just how much lower. So if I say what is the slope then?
Negative
What is that? What is the slope?
negative 5,000 over 1.
Yep. Whenever you have A that is that, you just basically minus 5,000. And you can say over 1 if you want to think about it that way, right? Because it's y over 1. So could somebody tell me, what is that actually saying? What is that actually saying?
That per year it decreases by 5,000.
Very good, right?
The value.
Right, the value decreased by 5,000. Right? The value decreased by 5,000. It means every year, because rise over run is the change in, right? Change in y versus change in x. And x is the year, remember that? X is the year, and y is the value. So the relationship is that for every year, there is a change of negative 5,000. Because you're losing, right? You're losing the value of 5,000. Okay? Remember that that relationship is a relationship that is defined by the slope. And what the B just means where you start. Remember that, right? B is just where you start. Because you didn't start with a zero amount of, you start with something high, right? Because it's an SUV, so you start with 30,000. Right? You started with a high number because your SUV was expensive. It was expensive. All right. So what I'm saying is that what the problem asks me to do is how do you use the mathematics that you have to talk about the problem in a way that is logical, right? So the rise over run is not an abstract concept. In real life, it actually means for every year that is changing, I have a negative $5,000. This is actually dollars, right? Because if you think about it, this is actually in dollars, right? Both sides is in dollars, right? On both sides, this is going to be dollars. All your numbers are in dollars, okay? It's what is it, the value versus what it started with, okay? So let's say I didn't know that the SUV is 30,000. How would I know from that problem? How would you know?
I would just add back 5,000. Because when you bought it, it says that the value of the car is what X is, and you're starting at 30,000. So I would think you're buying it what it's worth that year. So
what year is that?
Whatever. So it's 30,000.
Zero.
Yeah.
So X will be zero.
Okay.
So if X is zero, you haven't decreased any value.
Oh, so that's when you're buying it.
Because you just bought it, right? It's a year later that you lost $5,000. Okay? So understanding what these numbers mean actually helps you logic. It's that this is a very logical problem. It's a very logical problem, right? That if I started with X equal to 0, that means that I haven't moved yet. I haven't gone any year. I just bought it.
Yeah.
That means I don't lose any value. Then I can say, so if a question says, what is the original value of the SUV? How would you answer? 30,000.
30,000.
Because that plus B is the actual Y spot.
Yes,
Where you
you start, right? You didn't start with a car that has 0 value. You started with a car that is actually very high value, right? Very high value, all right? Does that make sense? So understanding how to talk, because sometimes the question will do this. They'll give you the equation, they even tell you the slope sometimes, and then it will say, according to this problem and this equation, what is the value of the SUV? Now they could have like 3 questions to the same problem, right? They give you the equation, they give you the little story, and then they ask, what is the original value of the SUV? You're gonna go, how do I know? Well, you have to understand what is the relationship between the years and the value, and you're gonna go, well, if I just bought it, my X is 0. I haven't lost any value yet. So therefore, my original value is 30,000. Now they might trick you and say, oh, I'm going to put a 1 there, and so my original value is 25,000. Or they may say the original value is 35, just to trick you. Okay? Because you kind of go, I don't know. But yet, if you do know, it's actually very easy, right? Because it's like, what? This is the relationship between the value of the car and how many years I have bought it. Well, when I just bought it, it's 0. I haven't even moved it out of the what do you call those things? Dealer, the car dealer. Yeah. What are those things called? Car dealer. Okay. So that question is I asked, what is the value of my original SUV? $30,000.
So what is that 5,000 in this case?
Okay. Remember rise over run.
Yes.
For every year that is changing. Okay. If I change 1 year, I'm losing 5,000. Okay. Let's do a table for this time before we plot. All right. Because this is a real life problem. So if this is Y and this is X, and so it is this is X. So this is year, right?
Yeah.
And then Y is actually the value. And it's equals to very big number, minus 5K X plus 30K. Does everybody know that, right? K is 1,000, so I'm just being lazy and do it that way. So when X is 0, what do we say Y is?
30,000.
30K, right? So what happens if I put x is 1? After 1 year, what is going to happen?
5,000.
Exactly, right? If you put 1 here, you lost 5,000. So that's 25, right? What happened if you 2 years? When you put a 2 here, how much did you lose?
20K. You're down
10K.
20K.
So then you are at 15K.
Oh,
Is that correct?
No.
No, wait, no, no.
20K.
20.
It's 20, so you're only going down 5.
Because it's coming from the original. See, I make a mistake.
Yeah.
You have to lose it from the original value. So it's actually 20. Because for every year, you're losing 5,000. So the third year will be 15.
Thinking the same thing.
Okay? All right? So this problem is logically makes sense. In real life, you actually do this. What you've just done is to say, how do I represent this? Right? How do I represent this in a way that helps me do the problem forever? Okay? If you want to like keep the value of the car, keep the car for 30 years, you can do the problem. And it's like, oh my God, it's not going to be a lot of money left.
So could they give us questions like the value of the car, and then current value, and then they give us how much it decreases, and then it asks us then what year?
Yeah,
the
there are many
value
ways
is
you can.
at. So
Yeah, you could. They could ask stuff like, what is the value of the car at the 5th year? What would you do?
Like
500, right?
Just plug
Now
in
you can do
5.
it this way. You can do it this way, or you can plug it into the equation. Either way is fine, and that's the key about algebra. You can do it by the table. Sometimes it takes a long time. Okay. You can do it by the equation. Okay. So you can do it both ways, or you can do it by the graph. So when I was teaching algebra in middle school, we always talk about how there are 3 ways to solve a problem in algebra. The table form, the equation form, and then the graph form. And depending on the problem, what you are being asked, some of them will be easier than others. Okay? In this case, the table is not bad because we know that it's losing value, 5,000 each year. We know that. Okay? So sometimes you can verify both and see, wait, did I get this right? If I put a 2 here, will I get the same number? If you didn't, that means something went wrong. Right? So sometimes the different ways of doing the same problem helps you make sure that you're on the right track. Okay? Now, let's draw it. So you may also say, the third question is, so maybe one question is, what is the original value of your SUV? What is the value of the SUV after 6 years, 5 years, whatever the number is? So you put X, right? Or you can do it in the table.
This is not a 1-minute question.
Well, it could be if you set it up here, it could be. It could be, because remember, you have all the answers on there, right? So it's a matter of elimination and say, oh yeah. So, but if those are 3 questions, those are 3 minutes. It's not considered 1 minute.
Okay.
So sometimes they will say stuff like, for the following problem, please answer 5, 6, and 7. See what I'm saying?
Yeah.
So they are each about a minute, but you are looking at the same problem.